Welcome to our tactical session on the wastewater management, the Cayman Islands perspective. In this session, there will be two presentations followed by a live Q&A session. My name is Tom van Zanten, the Deputy Director of the Water Authority, Cayman, and I will be moderating this session. First of all, I would like to thank our conference sponsors. We really appreciate the support of Cipp Contracting Cayman Limited, Deal Metering, MIA, Water Engineering and Pipeline Company Limited, Consolidated Water Company Limited, Data Enterprises Limited, Florida Aquastore, and Argo American. Before we get started on the session, I would like to briefly review a few items. You will have the opportunity to submit text questions at any time using the Q&A section on Whova. Questions will be answered during the live Q&A immediately after the presentation. This is a collaborative session where all in attendance will be able to engage in this discussion during live Q&A. Now I'm pleased to introduce our first speaker, Hendrik van Genderen. Hendrik van Genderen obtained his environmental engineering degree at Wageningen University and Research in the Netherlands in the late 1980s. He has worked for the Water Authority of the Cayman Islands since 1988 in various positions. As Water Resources Engineer, he manages the dynamic team of the authority's Water Resources and Quality Control Department. Focus areas of the department are management and protection of the groundwater resources of the Cayman Islands and quality control performed by the authority's accredited laboratory. The department is closely involved in the operations of the authority as a water and wastewater utility. In addition, the department deals with many environmental and public health issues that impact the quality of life in the Cayman Islands. Hendrik, you may now turn your microphone and webcam on and start your presentation.
Good morning, everybody who is attending this conference, and thank you very much, Tom, for that wonderful introduction. For this presentation, I also want to thank my co-authors for the paper, Yasmin James, Cody Scott, Trenton Foreman, and Corey, who all work closely with me. And also I want to thank the Water Authority for making this possible by using their data and their equipment. The agenda for today is a brief introduction about the subject. I talk a little bit about wastewater treatment in the Cayman Islands. You get a general picture of what we do here. The heart of my discussion is about how we have developed our on-site wastewater management program. I touch a bit on next steps, and then we talk about the conclusions of the program. So why do we have this talk here today? I think the topic of on-site wastewater management is a topic that will never go away in the Caribbean. Cayman Islands is in a very similar situation as many other Caribbean nations, and it is simply not possible to have total sewerage coverage for entire country. As you will see later in the paper, there's a large area of Cayman that just relies on on-site treatment, and that is the way it will be for a long time to come. That means actually that we should treat it not from a perspective as an afterthought in wastewater treatment, but we should really have a strategic approach to that. And that is the purpose of this paper, to see and to share how the Water Authority has approached this. It also follows up on the presentations from my colleague Catherine Crabb in 2003 and 2009 at the same conference. Let's talk a little bit about how it works in the Cayman Islands in terms of wastewater treatment. The Water Authority is operating under the Water Authority Act and the regulations. And among those tasks that it has to fulfill, it is the regulator in respect of on-site wastewater collection, treatment, and disposal. So that is important. We have a legal mandate to fulfill this function, right? If you don't have the legal mandate, then it becomes a lot harder. Where are we at this point in time in the Cayman Islands in terms of wastewater treatment? This is the map of the 3 islands. So Grand Cayman, Little Cayman, and Cayman Brac. Currently, we have a population of give or take 70,000 people, of whom the vast majority lives in Grand Cayman. Now you look at the red box on the screen, and that is the area where the Water Authority operates its central sewage system. That is the part we're not going to talk about today. I'm going to talk about the rest, because anywhere else in these islands, you have on-site treatment. So that means a particular system that literally on-site treatment is treating the wastewater at the site that it is generated rather than transporting it to a central system. So a couple of figures here. This is I think a fairly accurate estimate. We did that in December on request of PAHO, and it gives a bit of feel of where the wastewater in the Cayman Islands, where it goes. First of all, I have to be in mind that this country doesn't have much of a heavy industry or anything like that. So the vast majority of our wastewater is domestic in nature. About a quarter of that is collected and treated for the water authority at its wastewater treatment plant. That plant also is consistently capable of meeting our standard in the water authority regulations of 30 milligrams a liter BOD and 30 milligrams a liter TSS. I jump to the septic tanks for a second. That's about half of all wastewater generated in Cayman Islands is treated through septic tanks. Septic tanks provide primary treatment and they do not meet the effluent criteria of 30/30. We have ATUs, aerobic treatment units, or some people call them package plants. They do secondary treatment. If they are operated properly, then they do meet the particular standard. We figure that about 1/3 of these ATUs meet those standards. This is the heart of the paper and the presentation. I want to talk about the development of the on-site wastewater management program. The paper, if you read it, is better at giving a historical perspective because this spans a period of about 40 years that we have been in this business. But there's limited time for this presentation, so I mainly talk about the status quo for where we are now. And as said before, the law and the regulations, they provide a framework for the water authority, why we do what we do. We have that mandate. Now, I'm going to talk in the next couple of slides about these different elements of the program. And all these elements, they fit together. So they're not standalone because they interact with each other. And if you do one thing in one area, it affects something in some other area. In the first place, if a new development comes in, and there's a lot of construction going on in the Cayman Islands, even during the pandemic, it goes through the planning process, and the water authority gets to review it. We first determine whether the development falls in the West Bay Beach sewerage area. If that is the case, it has to connect to that. Anywhere outside, then we deal with on-site treatment. If the development itself generates less than 1,800 gallons a day, they are allowed to install a septic tank. If it exceeds 1,800 gallons a day, then an aerobic treatment unit is required. More details of the treatment systems for ATU, and we have upped the game in that respect substantially in the many years that we are in this business. An ATU needs to have certification to NSF ANSI standard, that is for domestic wastewater treatment systems. And if it has that, then it means also it is capable of meeting the standard that we have in our regulation. It needs to be installed by a registered service provider. I talk about that later a little bit, what that means. It goes through a fairly detailed review process before even the installation takes place. We have learned this the hard way. It's better to do a whole pile of that stuff up front, because once it's in the ground, it's a lot harder to rectify things that are incorrect. Once we've signed off on the particular design and proposed system, then the developer gets to go ahead and then they install it. At the end of that process, for the planning department, you need what you have a certificate of occupancy. Water Authority is one of the signatories on that document, meaning that we have to okay that the plant is meeting our requirements and specification. At this stage, for septic tanks, we're still having relatively basic design criteria, which have not really changed much over the years. And we have fairly detailed effluent well specifications. I will not discuss this because it will take too long this morning. The thing that you have to keep in mind is in the Cayman Islands, because it's a very low-lying island, It has karst terrain, and the way we dispose of effluent is through effluent wells. So I touched upon registered service providers, and those are the people in the Cayman Islands who, or the companies actually, who do the installation and the operation of management of ATUs. This is private sector, let's be clear about it. The Water Authority itself is not in the business of installing these systems. We are the regulator, right? For such a business to become registered with the Water Authority, you need to have a certified technician on staff. The certification is done by the Water Authority itself. We have a very capable trainer in our midst, and he provides training on the wastewater treatment course. These operators can follow the course, and once they complete the course successfully, they need to sit an exam, and if they pass that, then they get registered by the Water Authority. Every service provider needs to have at least one certified technician in their company, and then they can do business with the Water Authority. Among other things, they need to submit operation and maintenance records. What this means is a system of registering service providers that provides a level of quality control and consumer protection, because you can set a bar at this particular standard. Another important part of the program is our customized database, the Carmody system. It is customized software. We didn't invent it ourselves. It is from a supplier, and there we keep track of all the ATUs that are installed in the Cayman Islands, and there is an enormous amount of detail in that. That gives you an incredibly powerful tool, and it sounds a bit cliche, I would say, but really and truly, data is knowledge. If you don't have that information readily available, and we're dealing at this point in time with 610 ATUs spread out over the Cayman Islands, you will be forever digging through spreadsheets if you're looking for some specific information. This database is very, very powerful. Of course, the program, naturally, you need to do some level of inspections, right? So as I said before, inspections are done when ATUs are installed. That is at critical points of the installation process, and then at the end point when they are approved for the certificate of occupancy. So you make sure that the system that is new is working properly and everything is fine. Then of course afterwards you make a good start, system is working fine, but you need to ensure that over its lifespan it still is operating properly. So the Water Authority also does periodic inspections of ATUs. It is an area where we recognize that we can make improvements. So as a matter of fact, yesterday we had an interview for an on-site wastewater inspector that will be a new team member, and that person will be focusing on ongoing inspections because we need to strengthen that role. Inspections obviously also, whenever we receive a complaint, it is never dealt with by the phone, like, okay, this is not our problem. It is a standard procedure that one member or two members of our team go out and find out what is going on, because these are mechanical systems and sometimes things go wrong and they lead to overflows, things like that, and we go and check it out. Another very important tool in our toolkit is that the Water Authority Laboratory is accredited for testing for BOD and TSS nutrients and a number of other water related parameters. The accreditation means that if they do a test, it will be very hard to argue against the test result. And by having a capability in-house to do the BOD and TSS testing on effluent, we generate invaluable data, because a lab report is very hard to argue with. Oops, my apologies, I did something wrong. Our program also has a very strong public outreach component, and Water Authority functions there as the regulator, but we have established a very, very good working relationship with service providers. There is day-to-day contact with many of these companies, and we also just general customers in the field, developers, homeowners, anybody, they know to find us, they call us, and we provide them with information. Also, it is a powerful tool. The website of the Water Authority, I really invite you to have a look at that. It has a really incredible amount of information about the on-site wastewater management program. That is a result of many years of hard work. We have, in terms of staff, we will have soon, we have 4 designated staff. So these are the people who basically their primary responsibility is to deal with the program. That is important for if you deal with so much proportionally of the wastewater in on-site wastewater in the Cayman Islands, then we need to ensure that the sufficient staffing and resources are available. And the last point is that we also have the tool of enforcement through the Water Authority Act and the Public Health Act. I must say that is a cumbersome process. So if we can help it, we try not to let it go to enforcement if things go wrong. Oh. I'm sorry, I'm having. Okay, next step, sorry. Where we want to do next with the on-site wastewater management program, we need to ensure that we continue to develop it. What we're doing today is not good enough for what we do in 5 years, 10 years, 15 years down the line. So this is normal areas where we be looking at. I talked a little bit about when we allow a septic tank versus when we require an ATU, and we have to recognize the septic tanks do not meet the 3030 effluent standard. So we want to tinker, improve the rules for when we install an ATU so that we get more ATUs rather than septic tanks. ATUs, this was the subject of the paper that was presented in 2009 by my colleague at the conference. ATUs are capable of meeting the standards, but they have to be operated and maintained properly. We have made a lot of progress in that area, but we still see room for improvement. So the training that we have now, we will gonna improve that by offering more training to deepen the program, and so that the service providers become more knowledgeable, more skillful, and they can do that job better. As I talked about, we are going to employ a dedicated inspector that will help us with extra data gathering in the field and knowing what is going on there. And we will continue the public outreach and education, very important element of the program. Other areas, and this falls more, I call it in the, I think it falls in the climate change category, all these issues that are shown here. ATUs have a fair, some of them, they use a fair amount of energy. Developers do not necessarily always consider that. So it is important that we educate the public that if they install these systems, that they also should be looking at the energy use of the particular systems, because there's systems that have a lower energy use versus those that have a higher energy use. And long term, that makes a big difference. So we are going to promote this further in our program, that we encourage the developers. They have a choice, some systems that they use as long as they're approved by the authority, but really and truly, they should also look at the energy use of these systems. The climate proofing is also important. All of us here in the Caribbean, I think, keep track of what is coming, and it keeps the predictions are getting more somber, so to speak. Our issue in the Cayman Islands is maybe the rising sea levels. That means if you are on an island that is very close to mean sea level, we may be partially underwater in 50, 80 years to come. That means that when we install ATUs and septic tanks, actually, we need to ensure that its minimum elevation is being maintained, and we are wanting to up the game in that respect. And then last but not least, we also want to look at better at any effluent reuse issues. Sorry, I'm having trouble with the slides advancing. Sorry. My concluding remarks are this on-site wastewater management program is basically the result of what the Water Authority has been doing for a period of 40 years. And it has improved over time, and it will continue to improve. And we will continue to look critically about what we achieve with the program, what we will not achieve with the program, and make adjustments and improvements to ensure that we keep focus on this area, because it's like where the whole presentation started. A vast majority of wastewater in all these islands is not treated by central treatment plants, but is treated on site. So we need to continue to focus on this program. This is my presentation. Thank you. And I think we can now move to the questions.
Thank you, Hendrik, for your presentation. Now I would like to introduce our second speaker, Breandan McDonnell. Having received his Bachelor of Engineering Honours degree in Civil Engineering in Ireland, his experience to date is as project engineer. Breandan has worked in both structural and civil aspects of engineering. Prior to his arrival in Grand Cayman, he worked for a large civil contractor in Ireland, where horizontal directional drilling and tunnel boring was the specialty of the contractor. His current position with the Water Authority Cayman is as civil engineer on the wastewater collection site, where the collection system is being upgraded and rehabilitated with the use of pipe bursting and manhole replacement. Breandan, you may now turn on your microphone and webcam and start your presentation.
Excellent. Thank you very much, Tom. Good morning or good evening, ladies and gentlemen, depending on what or where you're watching this presentation from. But my name is Breandan McDonnell. I'm a project engineer at the Water Authority Cayman, and this is my presentation on pipe bursting, improving the Cayman Islands wastewater collection system. So let's get the hang of the slides here. 1 second. So we can jump straight into it here. So you'll see that this slide is entitled Presentation Introduction. I'll give you a brief explanation of what I plan to discuss today, but more importantly, you'll notice from the slide that it's in specific regards to pipe bursting, the Cayman experience. Excuse me. The rationale behind deciding to examine this topic and method is that it's a relatively new method of pipe replacement on Grand Cayman and in the Caribbean in general. So it's an interesting area to say the least. So yes, in the essence of time, I'm not going to go through all the points here that's on this slide, but just to give you a flavour of what the presentation is going to be about today, some of the points we'll look at will be, for example, the history of pipe bursting, previous condition assessments of the network, cost comparatives and parameters in deciding to use the pipe bursting method, some planning associated with it and some challenges. So moving on then to the history of pipe bursting. So essentially pipe bursting was started in 1981 when contractors DJ Ryan and Sons Limited and British Gas successfully burst a cast iron gas main by using a piercing tool in England. After months of research, development and field tests, Ryan and British Gas patented the method. In addition to British Gas's need for pipe bursting, a substantial amount of cast iron piping already in place throughout Europe was failing, and therefore the method of pipe bursting was born. Alongside this, on the table on the bottom right of the slide, you'll see a table showing the uptake of pipe bursting throughout Europe quite quickly between 1983 and 95. So on pipe bursting itself then, so there are 3 methods of pipe bursting. You've got pneumatic, hydraulic, static pull, and the main difference between them is the source of energy and the method of breaking the old pipe. So pneumatic and hydraulic methods use a dynamic force to break the old pipe, whereas static pull uses a constant pull force. You notice the image in the middle top of the screen, an important image to note, as regardless of the type of system, be it pneumatic or static pull, you'll most likely see this configuration of the pipe splitting head, which actually breaks and splits the existing pipe. Then you'll see the expansion shell, which forms the middle part of the apparatus, and then also you'll see the HDP pipe at the end. The expansion shell itself is important to note. The expansion shell itself makes room for the following new pipe, and then you'll see the actual HDPE pipe at the end, which is the common practice. So the image on the left shows a pneumatic hydraulic system of pipe bursting, and the image on the bottom right shows the static pull system. Essentially, the main difference between them is the direction of force applied. For our operations here on Grand Cayman, we use the static pull system. So yeah, moving on. So the rationale for pipe bursting on Grand Cayman. So the reasoning behind this method of pipe bursting here on Cayman was examined as part of this paper and presentation under the following headings that you can see on the screen. From left to right, they're an aging collection system. Moving on then to pipe network expansion needed due to population growth, and then on to pipe network expansion needed due to the increase in building and property developments on the island. So if we take the first one first, have a look at the first one here on the left. Of an aging network. So most of Cayman's current wastewater collection network is made up of vitrified clay pipe. It's a brittle material, good in compression but poor in tension. You can see a picture on the very top left there of a vitrified clay pipe. Alongside this, on the left also, we've a screen. We've a picture that shows an old manhole that actually forms. That's a picture of a manhole taken from our existing network. And also you can see the new manhole that's taken its place. Point here is you can really see the disparity between the old and the new of the lined manhole, which is what we use now. Excuse me. Moving on then to an expanding network due to population growth. So in the middle of the screen, you'll see two graphs. These graphs are taken by a report called the Pedley Report, published by Dr. Robert Pedley in 2007. And these two graphs essentially outline the trends in population growth on Grand Cayman. And point here is that Dr. Pedley suggests that the island will have a population of 100,000 by 2030. You'll also see in the graph on the bottom, which shows that even with a natural disaster, for example, like Hurricane Ivan, the population trended upwards soon after. So a similar situation is likely to be expected as we slowly enter a post-COVID environment, essentially meaning that as a local authority, we need to put plans in place to keep up with the expected growth. More people essentially means more waste produced. And then the third point on this slide, which is an expanding network due to an increase in property developments. So an important side note here is that the average human produces between 50 and 70 gallons of waste per day, coupled with a population trending to 100,000 by 2030. And then also add this to a recent trend on Cayman of 10-story construction. It's safe to say that upgrading our network is vital to keeping ahead. It's vital to keeping ahead of the curve with regards to wastewater. So moving on then to an overview of the existing network. So basically, like any other wastewater collection system, the waste flows from the various developments via gravity sewers, then onto lift stations, and ultimately the main pump stations. As part of our network, pump station 1 is obviously the main pump station, and it's located on the south of the network. From here, the waste is conveyed to the wastewater treatment plant, which is a sequence batch reactor. The reactor itself has a capacity of 2.5 million gallons per day. The network itself, the network's installed in the late 80s. The overall length of the collection system is 12.5 miles long. You'll see an image on the left which illustrates the extent of the network. The image in the middle then shows the clay pipe and the agri-line manholes that we use as part of our collection system. And then also a picture shows the SBR plant. So from here, I suppose I'd like to elaborate a little bit more about the material in our network. So that is the vitrified clay pipe. So vitrified clay pipe did at the time have its place in wastewater collection systems. It had the benefits of being inert, which makes it highly resistant to chemical degradation, high longevity. Obviously, if the pipe isn't damaged before it's installed, it has good structural integrity with regards to deflecting or flattening under loads. That being said, in January 2020, Grand Cayman was subjected to a 7.7 magnitude earthquake, and from examining the pump run times in the days following the earthquake, a spike in pump run times could be seen, evident that the brittle clay pipes had fractured and allowed I&I, which brings us to the negatives of using clay pipes as a material for the collection system. So looking at the three images on the right, which were taken from our own existing network using CCTV, it's evident that clay pipes are susceptible to breakage and cracking, which then leads to root ingress, which further damages the pipe, and eventually replacement is needed. So that summarizes that one of the existing network. So moving on to the next slide. So previous condition assessment. So you'll see in the slide in front of you at the moment that an explanation of the previous condition assessments of the network. So the first point here is that we used to use a GoPro camera and CCTV. We still do use the minicam CCTV for pipelines. It's very effective in dealing with the survey of the pipeline integrity. But as technology advances and the Water Authority Cayman have basically invested in the use of a Q spider cam. So you'll see the image on the right there, which is the spider cam. Spider itself is a scanner that can calculate its position in the manhole shaft by using sensor data to measure its incremental motion. Spider collects millions of 3D measurements during each manhole inspection. The raw data itself is then processed to a 3D point cloud that provides engineering and survey quality information on manhole geometry, the condition assessment of the manhole, and also structural integrity of the manhole. So it's an extremely beneficial tool for the use on our network here on Grand Cayman. So some previous remediation methods of our network. So before we dive into the type of remediation methods that took place over the years on Grand Cayman, we'll firstly examine why remediation needs to happen. So basically, in sanitary sewers, splashing and turbulence happens where pressurized flow discharges to gravity pipes, releasing hydrogen sulfide into the air, or H2S gas. Where hydrogen sulfide exists in sanitary sewers, bacteria feeds on hydrogen sulfide and excretes sulfuric acid. This sulfuric acid then quickly corrodes the concrete of the manholes and of our pump stations. So, and the corrosion is specifically damaging to obviously the unlined manholes. So, with regards to the pipe network, it's mostly due to ground movement and age, which has caused the pipe network to break and crack. And the two images on the top show the manhole degradation. Or sorry, the image on the top shows manhole degradation due to H2S attack, and also on the right, then top right, you can see a clay pipe succumbing to root ingress. The next three images on the bottom of the screen from left to right show the remediation methods that were put in place for manholes and pipes, and they're obviously listed from left to right in the year in which they were carried out, starting with the earliest in 91. So you can see in the bottom left, you got the Amaron T-lock liner. So that was a project that took place in 1991-92, and basically it's a liner that's cast in new concrete and essentially using the old concrete manholes and outside form. You can see from the image that the liner itself has a T-lock configuration in the actual liner that anchors it to the new concrete. As part of this project, a total of 76 manholes were rehabilitated using this method. The middle image then in the bottom, you've got the FIPP liner, so also known as U-lining. The FIPP method was used in 92-93, and with the FIPP method, the liner is already impregnated with a resin and a hardener. Once the sleeve is pulled through the damaged section of pipe, hot air or steam is pumped inside, causing the liner to expand, harden, and take the shape of the damaged pipe section. And the total length of the pipe that was rehabilitated as part of this project was 5,000 feet and consisted of both 6-inch and 8-inch nominal diameter sewer pipe. And CIPP, so finally looking at the last picture on the bottom right, we can see the CIPP liner method. During the period of 1992 to 2013, the Water Authority identified further leaking sections of pipeline comprising approximately of 2,100 feet of 6-inch and 3,000 linear feet of 8-inch nominal diameter sewer pipelines. CIPP, which is cured in place pipe, much like FIPP, is a trenchless method of rehabilitating sewer pipes. CIPP line is used in the repair of existing pipes. It uses a textile liner tube and a liquid resin, and basically the process begins with the wet out stage. So during this stage, the textile liner is impregnated with a resin mixture, an epoxy base, and with a predetermined hardener. Next, the liner is inverted into the pipe with air pressure. The resin will now be on the outside of the liner. The liner will be against the existing hose wall of the pipe. After inversion, a calibration tube is inverted inside the liner, which can then be ambient hot water or steam cured. And during this period, the curing agent activates and causing the resin to harden, creating a fitted, smooth and corrosion-resistant new pipe wall. So following on then to remediation methods continued. So basically, following on from the previous slide, I'd like to explain a quick overview of the further remediation methods that we now currently use as part of the network rehabilitation, and that is HDP pipe installation for the clay pipe replacement, and also agri-line precast concrete manholes. These methods now take precedence with regards to maintaining and rehabilitating the network. The installation of manholes now becomes quicker, also have a longer lifespan using this product. And I suppose it's important to say on the HDP installation side, the material is extremely versatile and it meets all the requirements for the wastewater lines and sewer pipes. So why we implemented pipe bursting on Grand Cayman? Well, the FIPP method of relining pipes have produced just over a 98% success rate, with only 2 sections of 107 sections that actually re-inverted, essentially meaning that the pipe lining material had failed and ultimately led to a collapse in the material and therefore a blockage in the line. A similar situation in 2013 was observed whereby the CIPP method of relining also failed, again causing the liner to clap and causing a blockage. The remedial methods of repairing these issues, coupled with a slight conflict between the water authority and the chosen contractor, ultimately led to the water authority having to excavate these areas and relay a new pipe. So in essence, the point is that the method which was due to rehabilitate the network using the FIPP and CIPP ended up becoming the method causing the problems of blockage in the area. The observations and conclusions of the Water Authority indicated that the most common vulnerabilities of the epoxy lining systems are associated with planning and quality of the preparation, as well as the training of the applicator personnel performing the installation. With short of 100% video documentation, there's little or no way of knowing with complete certainty how well the pipes were cleaned and prepared for the epoxy application, which is directly correlated with whether the epoxy will adhere properly to the inside of the pipe or if an adequate coating was blown into the piping system. So moving on then, the Water Authority Cayman's first pipe bursting project in Grand Cayman. So Water Authority Cayman first implemented the use of pipe bursting on the 27th of February 2019. The location was Lawrence Boulevard, which is roughly forms middle part of the network on West Bay Road. The burst was conducted between manholes 2401 and 2487A, and basically consisted of 200 feet of 8-inch vitrified clay pipe, replacing that with 10-inch HDP butt fuse pipe. The clay pipe had collapsed between the two manholes, and due to the collapsed nature of the pipe, the implementation of the lining technology wasn't an option. The image in the slide in front of you now shows the location of Grand Cayman's first pipe bursting project. The main point that I want to take away from this is that basically this area, Lawrence Boulevard, it's essentially a heavily trafficked area, and this is what the essence of pipe bursting is all about, and that is rehabilitating pipe in a heavily trafficked zone with minimal disruption to traffic and residents and minimal disturbance to the ground. And basically, as far as excavation is concerned, it's only entry and exit pit. That's all that's needed. And in the case of this situation, the manholes are also in need of replacement. So essentially, we killed two birds with one stone. The pipe was replaced, and also the manhole excavation acted as entry and exit pits, while at the same time being replaced. So moving on then to pipe bursting versus traditional methods. So basically, we can see this slide is entitled Cost Comparatives and Parameters, and this was an actual cost comparative study done when deciding. Now, it's granted it's a summarized version of it, but this was the actual comparative study done when deciding to use the pipe bursting on Grand Cayman. So care was taken at the time to meticulously go through in detail the different options based on cost and also the practicalities of using pipe bursting versus traditional methods. So some factors to consider at the time are outlined in the slide above. You'll notice in the slide that each method is listed and a cost concern attached to each method. So let's first look at the traditional method on the left, which is the open cut and repair method. And I'm not going to go through it word for word, but you'll notice that in terms of workload, it has the most items attached to it regarding its cost. Again, the cost itself has a large number of items attached to it as well when compared to pipelining. And based off previous projects, pipelining wasn't even considered. So moving on to the right-hand side of the table then, you can see the works to be completed and cost concerns. And based off this, a decision was made in 2013 to use option 3 on a time and materials basis using a specialist contractor called Cipp Contracting Cayman Limited. So basically, to conduct its pipe bursting operations, that's who we used. And at the time of the first pipe burst operation, there were several other areas of concern that needed urgent attention and for which pipe bursting was the preferred option. So in regards to costings of pipe bursting versus traditional methods, it's important to state that there are a number of additional costs to consider when making repairs to a pipe. So for example, traditional trenching repairs don't always include the cost of excavation of the old pipes. Trenching costs far more if the job is especially complicated, and in some cases it may even require other contractor to perform the work. Also, any large heavy objects that's located near or over the sewer pipes or the collection system, there may be separate charges for relocating them before and after the work's complete. And again, this is just we're taking a brief insight in here into possible additional costs, and that's just two straight off the top of my head. Even if the price of the estimate does cover the cost of digging off the pipe, it won't include the cost of replacing the landscape, replacing of concrete in a homeowner's yard. A lot of the time, professional landscapers need to be hired to get things back to the way they were, which could run into thousands of dollars. Also, when doing repairs for commercial sewers and water pipes, the act of trenching can be extremely disruptive for business operations by blocking off sidewalks, diverting foot traffic to possible business, driveways or signage that needs to be erected, that kind of thing. So if the project drags on for longer than expected, it could result in a loss in productivity and make it difficult to conduct business altogether. So trenchless technologies can bypass these costs because they're minimally invasive. There's no way to there's no need to rip up landscape and sidewalks, and just overall resulting in less disruption to business. So on the planning side associated with pipe bursting, so on the slide now you'll see the planning associated with pipe bursting, and the Water Authority follows a particular flow of work in relation to pipe bursting on Cayman. So carrying out the work is one thing, but it's the planning involved that allows the actual pipe bursting to be conducted. As we are working on behalf of the public, it is important to keep the public informed as to possible disruptions, which in turn avoids any complaints and makes them aware of the works being conducted. So firstly, you'll see hose pipe examination. Well, this is done by CCTV. This allows us to see the condition of the hose pipe. The reason for this is using pipe bursting, pilot rods need to be fed through the existing, for example, clay pipe. The pilot rods are fed through the pipe, and that's what we're used to pull back the HDPE pipe. Next point shows a survey of the existing pipes and underground structures. So in almost all cases, we encounter other services and utilities in the proximity to our operations. So it's paramount that we don't interfere with other services which may cause huge disruption to fibre optics or water. The last thing that we need would be to burst through a fibre optic cable or to burst the water pipe. So that's not good news, obviously, for anyone. Also, when conducting pipe bursting, customers do need to be notified that works may encroach on their property, especially in the case of drilling drainage wells. So basically, the point here is that due to Cayman's high water table, we do need to be able to dispose of the groundwater during entry and exit pit excavations. So therefore, we do need to be able to, wells do need to be drilled sometimes close to or sometimes on the proximity of the owner's boundary. And we endeavour to reinstate the ground conditions to the original format just for customer satisfaction, and obviously because it's the right thing to do. A notification is also sent to customers in the area just to keep them informed and keep them in the loop as to the works being conducted in the area. And finally, the drilling. So the drilling of drainage wells already touched on point 3 of this slide. But again, the reason is to dispose of groundwater during the entry and exit excavations. So moving on, then we have the local availability of a contractor. So in relation to the availability of a contractor, outside of general building and structural concrete works, there really is no contractor that specialises in pipe bursting on or trenchless technologies on Grand Cayman. So pipe bursting and trenchless technologies tend to be a specialised method of pipe replacement, and contractors who use this method tend to be somewhat experts in the field. With that being said, Sandpick Contracting Cayman Limited is the chosen contractor that we use in order to conduct our pipe bursting operations. So challenges faced during pipe bursting on Grand Cayman. So yeah, moving on to the next slide, you can see a few points in relation to the challenges. I suppose the main challenge would be that outside of locate requests and health and safety, traffic management, and just general organising, and the one that greatly affects the time and efficiency of a project on Grand Cayman is the groundwater itself. So most aspects of pipe bursting projects can be planned for. Groundwater, however, cannot. All pipe bursting projects conducted so far on Grand Cayman and in the Water Authority Cayman's network have ran successfully. And what I mean by that is successful in a sense that they were completed, but not without the difficulties of fighting the intrusion of groundwater during localised excavation. As the Water Authorities, the main sewer network is located mostly below the water table, coupled with the fact that the region is mostly made of coralline limestone and jointing karst formation. It leads to most pipe bursting projects encountering fissures that allow high flow rates of water. And essentially the remediation measures for dewatering on Grand Cayman are with the use of deep wells, whereby water is disposed of under pressure to a deep well. So if you take a look at the image on the right, at the right of the screen right now, you'll see the specifications the Water Authority has on deep well configurations. You'll see in the very top in the red that is it's a pump hose essentially, and these discharge pump hoses are hard piped directly to the deep well, and the water is disposed of by forcing water into the deep well, where it moves then laterally through the open zone, which is denoted on the bottom of the screen. So this brings us to the last slide, which is the conclusions. As part of this presentation, we've looked at alternative methods of pipe replacement and alternative technologies that can be used in order to make our wastewater collection system better and increase its lifespan. And some key points here would be looking at the existing network, or some key points that we've looked at would be the existing network, previous condition assessments, previous remediation methods, alternative trenchless technologies, and cost comparatives of traditional versus pipe bursting. And I suppose making a viable case for pipe bursting as a trenchless technology for use here in Grand Cayman was a relatively easy one, and the reason for that is simply that the Water Authority has examined all the other methods of pipe replacement, and pipe bursting itself as a method has proven itself in being the most efficient and the method by which collateral damage to the surrounding environment is kept to a minimum. Like with any civil engineering task, the method of improving Cayman's wastewater collection system does not come without its challenges and hard work. Finally, I'd like to leave with this quote. With that being said, I'd like to leave with this quote from Michio Kaku, which I feel is applicable to us here at Engineering Services, and that is, what we usually consider as impossible are simply engineering problems, and there is no law of physics preventing them. Definitely applicable in relation to pipe bursting here on Grand Cayman. That concludes the presentation, and thank you for your time.
Can you hear me?
Yeah, you're on now, Tom.
Okay, sorry.
Your video's off. There you go.
Okay,
Yeah.
sorry, we had some technical issues. Thank you, Breandan, for your presentation. At this time, everyone in the session may participate in Q&A. If you have any questions, you may submit them via text on Whova. We will do our best to answer all of your questions. If we run out of time, you can find Hendrik and Breandan's contact information on the speakers page on Whova. Whilst we're waiting for some questions to come in on the chat, I have a question for Hendrik. You mentioned that about 1/3 of the ATUs meet the requirements of 3030 effluent. What is the process to deal with the remainder, the majority of those ATUs that don't meet those standards? And at what time does the Water Authority consider issuing notices of violations?
Well, the main issue is here, and that's what we learned when Catherine, my colleague, presented the paper in 2009. She found that 8% of ATUs was not working. Now we're up to the third or a quarter of that they are working properly. What we did with the entire program that we have here, and I think that is maybe my whole message to anybody who's listening in here, is that we continue to fine-tune and improve what we're doing. So what we learned over the years is that we need to work harder. Well, not so necessarily harder, but smarter in what we do. And that's why we attracted additional resources. The training program that we have set up, that is has had its fruits. Now we're going to employ an inspector. That will also make an improvement. At some point in time, once we have done everything that we have to do and we can do in this area, then indeed the homeowners or developers that continuously will not listen to us in that sense, if that's the right word, and they neglect their systems, then it is time to issue notice of violation, because these systems, in the end, they can work properly, and if they don't maintain them, then it's basically what goes in goes out, right? I wouldn't say the notice of violation are a last resort. That is what you do with people that don't cooperate. Quite often what we experience, if we put more pressure on it and we explain what we're doing, then we get a lot of better buy-in into the program.
Okay, Hendrik, I'm asking a question to Breandan now. There's some problem with your mic, so your sound is not coming in very clearly. Breandan, you talk us through why we use the static pool method of pipe bursting rather than the hydraulic or pneumatic method?
Yeah. So basically, we touched on the types of pipe bursting. So we said pneumatic, hydraulic, and then the static pull. Well, the reason behind using the static pull, I suppose, Tom, was twofold. Number one, and the main one really was that simply it's because we use a specialist contractor for this. That's the type of equipment he has. And I suppose secondly, from an environmental and a noise pollution point of view, the static pull exerts very little noise, whereas the pneumatic and hydraulic systems offer a percussion type motion, which can offer some noise pollution. The static pull exerts very little noise other than the pipe breaking inside the ground, which is extremely harmless. And that being said as well, the noise is actually muffled by the ground itself. Like, so yeah, essentially it's the static and pneumatic, or sorry, the hydraulic and the pneumatic offers a percussion, whereas the static pull is just a constant pull force.
Okay, well, thank you. So you mentioned something about the spider camera.
Yes.
So how do you see that be beneficial to reduce the I&I on the wastewater collection system?
Yeah, so the spider cam itself, I touched on the fact that it takes millions of measurements. It's all sensor data. Basically, it's pretty accurate to 1 millimeter. Pretty much, this being said, it gives us an overall color image of the inside of the manhole itself. That coupled with the fact that basically from a structural integrity point of view, the spider cam will help with that. But when we roll out that program of the spider cam, we'll also be testing the conductivity and salinity inside the manhole itself from the lines that lead into the manhole. So that as well will give us an idea of the type of I&I or the I suppose the level of I&I that's coming into the manhole itself.
Okay, thank you. See, Hendrik is back. So Hendrik, the threshold of the 1,800 gallons a day between the water authority's requirement for ATUs as opposed to septic tanks, what is that based on? What's the calculation method used? Hendrik, your microphone?
Yeah, you're on mute, Hendrik, I think.
No, it must be on your headset. Technical problems. Okay, well, maybe we continue with you, Breandan, in the meantime. Yeah. So it was a long discussion about pipe bursting versus traditional methods. I mean, obviously, we have this issue here with the high groundwater table, and maybe you can expand a little bit more on, or you did already, but the difficulties of having a traditional open cut method in the circumstances that we experience here in the Cayman Islands.
Yeah, so I suppose in relation to that slide itself, I suppose you're probably talking about the it's entitled cost comparatives. Even though it doesn't actually have a monetary value attached to it, but yeah, I suppose at the time, I suppose right now I can't provide an actual cost association with each method, but there is many variables that need to be taken into account when you do a direct comparison between pipe bursting and traditional open cut, or even the liner method. But in particular, the pipe bursting versus open cut, there's many factors such as traffic management, but the main one would be reinstatement. These kind of costs associated with open cut can run into the thousands, whereas you must remember with pipe bursting itself, all we're doing is creating an entry and an exit pit, and we're replacing the pipe. It's minimally invasive. It's a non-trench method essentially of replacing the pipe, and that's probably the best description I could give to you. So yeah.
Okay. So some question came in and say, are you limited with the pipe diameter by the host pipe, by the original pipe?
Yeah, not in particular. You're not limited to what you can replace, but usually the general rule of thumb for pipe bursting is you're upsizing. So, for example, if you want to install if you have an existing 8-inch pipe and you want to replace it, you go 2 sizes up, so that would be 10 inches. The only limitation essentially would be, and obviously we don't have the experience here on Cayman, because we've only replaced, I think, 12-inch so far with the pipe bursting method. But basically, the only limitation is the size of the machine that you have is the pipe bursting apparatus itself. The bigger the apparatus is, the bigger the static pull apparatus is, the bigger the pipe you can pull through the ground, essentially.
Okay, so when you're using polyethylene pipe, obviously they come in certain lengths, 20, 40 feet lengths, and they fuse together. How do you test the integrity of the joints between one pipe and the other, the fuse?
Yeah, so that in itself, that's actually down to the contractor that we use. So they use an external body, an external testing. The weld itself gets audited. I saw it's probably, for use of a better word, with a company in the US. The machine itself, the fusing machine itself, basically it has a data logger on it. So essentially, when the pipe is fused together, the fusing machine itself sends data to a logger and basically says if the pipe is passed or not. We have used back home, we've used the general site test of a twist test where you tie a knot in the fuse and things like that. But the data logger itself suffices in terms of determining whether a fuse is substantial or not.
Okay, and the termination of the pipe in the manhole, how do you ensure that the seal is done correctly? We have no infiltration at that connection.
Yeah, so as the new HDP pipe protrudes into the manhole, the new manhole, basically we line that area, the OD of the new pipe in hydraulic cement, and most times it gets an epoxy coat on it as well, just to double proof it, so to speak. So we've never had on any job we've done yet on Cayman, we've never had any infiltration from the seal around, from the annulus of the new pipe in the protruding into the manhole.
Okay, thank you. I think Hendrik is back. Hendrik, I'll just maybe you should redo the answer to the question with regards to what do we do when ATUs do not perform as required.
Yeah, can you hear me now?
Yes,
Yeah.
It's much better.
Oh, thank you very much. Okay, so ATUs in principle they can meet the effluent standards, but where they do so if they are properly operated and maintained, and that is where we try to put the thrust of our program at this point in time. The employment of our inspector and on-site wastewater inspector are two elements that are very important to that. And what we do, anyway, it's actually the same way as we've been talking about this whole week. It's about training and education, and that's what we do with the on-site service providers. We are trying to go and up the game to improve that. There are instances though where systems are installed and the owners are neglecting them. In that case, and if we don't get anywhere with them, we talk to them, we have a dialogue on whatnot, but if they don't do anything, we have the option of a notice of violation. And that in the end, if that is not followed through, that can follow through in enforcement. I must say though, enforcement, it is a very cumbersome process under the current circumstances. We have to make a case, it has to go to the courts, it has to be treated there, and that takes forever. So really and truly, we would place our bets on the better education and improving the program as a whole, and that's as a matter of fact, that's what we're doing.
Okay. On a related note, then, you said you have 3 full staff, maybe 4 soon. How do we recoup the cost of all the education, inspections, and all that? Is there a way to recoup that in the Water Authority's tariffs, or how is it paid for? That's
a very good question, Tom. And in my presentation, I didn't touch on that actually. In the Cayman, it's quite a
maybe it's a novel way, I don't know, but somebody has to pay the bill, right? And so the Water Authority, as a regulator, this is what we do. It's about 2 years ago. There was a mechanism introduced in the water rates. This applies to Cayman as a whole. So for the municipal water rates that you pay, a small proportion of that is funneled back to the Water Authority for this regulatory function that we have. So that provides the funding. And that is actually very important, because I can just sit here and say, you know what, to all the other islands, you need to develop this on-site wastewater management program, and there's all the bits and pieces that you need to stick in. If you don't have the money to do that, and the money is not made available in one way or the other, then you won't go anywhere with that, and the program just will be left by the wayside, and nothing will improve. So the funding is essential, and through the legislation, a very nimble mechanism has been created to that for all the water on your water bill, portion of that goes back to the function that we do here to protect the resource.
Okay, thank you. Well, unfortunately, we come on to an end. The time run out. So the session now come to an end. We hope you all enjoyed it. Remember, if you have additional questions for Hendrik or Breandan, you may reach out to them by phone or email. You can find this information at Hoover. Finally, I would like to encourage you all to visit our virtual exhibitors and sponsors booths to learn more about what they offer and how they can help you. On behalf of the CWWA and the Water Authority Cayman, we are so glad you joined us. Thank you for attending.